So, equilibrium and change. Now, those two terms are actually opposing terms. They really mean the opposite. I guess that's what opposing is. I guess I just repeated myself. Does anybody know what it means for a system or something to be in equilibrium? Does anybody know? Yeah, Jess, what do you think? That something is equal? Yes, I like that. It definitely has some equality to it. Correct, yes. Yeah, very good. It maintains a constant state over a period of time. Excellent. There are many different situations that we can have equilibrium in the other sciences. Again, the other sciences are my strength. In physics, we say that an object is in equilibrium when all the forces on it are balanced, and it's just kind of holding there. So right now, each of the desks that you're sitting in are holding you up. You're not crushing the desks and falling to the ground, and that means there's an equilibrium there, all right? And that's called static equilibrium. You're just being held in place. In chemistry, we have equilibrium reactions. We have chemical reactions that can actually run in both directions, and they just balance out perfectly for the amount of stuff that there is in that reaction, and it looks like it's kind of hanging on there. We call that a chemical equilibrium, all right? We have encountered this idea of equilibrium already. We encountered it in our predator-prey scenario, where if we had a population graph, all right? And remember when we had population versus time, all right? And it did this type of thing and then did this type of thing, all right? We would say that in this particular scenario right here, that it's reached some kind of equilibrium, all right? Again, we could have a prey or something like that follow in behind and, you know, competing with that. Not competing, but being a predator-prey scenario. And in the end, we've got a balance between the predators eating the prey and the prey reproducing, and then the predators eating the prey and the prey reproducing, et cetera, et cetera. So that's like an equilibrium. We were talking about predator-prey relationships when it comes to the animals, right? The lynx and the hare, right? But we could also talk about plants, not necessarily being predator and prey. That would be hilarious. What, a man-eating plant? That would be a little scary. But we could talk about a plant population where the population goes up and then it runs out of room, and so some of them die, and then there's more room, and then some of them grow. You know what I mean? So we could still get this population fluctuation with plants, all right? So we want to talk primarily about plants today. So then, when do we have an equilibrium, and then what results in the change? That's the second part of it. Okay, let's click on and advance. Let's describe the equilibrium. Oops. So the equilibrium describes a biome or an ecosystem that has been established for many years, and that system looks as if it's kind of constant, but there would be minute changes taking place within it. And that's really what defines an equilibrium. It looks as if it's achieved a state of not change, but there's little changes always happening. So yesterday you read about different biomes. To be honest, I didn't look that closely at it. That was me being a bad teacher. I just made you write it instead of me having to learn it. Bad. I should have read it closer. I believe there's one called the boreal forest. Am I correct? Boreal forest. And boreal forest, is that a coniferous forest? Okay. That doesn't work very well for our area here. What area are we in down here in the southwest? You guys had to do a little map. There's a little bit in southwestern Ontario. I guess it's not boreal forest because there's not there is pine trees, but there's not piles of them. What is it? Is it just called the deciduous forest? Is that what it's called? Temperate deciduous? Okay, all right, excellent. If you take a look at what we call around here a woodlot, you know what I'm talking about, where there's a little forest in between the cornfields or the bean fields? It tends to be at the back or the middle of the side roads. You know what I'm talking about? You go halfway through a side road, you got a woodlot, and then you got the other half. Well, southwestern Ontario used to look all like that. That's what the whole thing was. Very diverse. And I guess that woodlot is a little bit of a peek into an equilibrium system. Okay? In other words, it hasn't been disturbed, hopefully not too much. And, you know, trees are growing, some are dying, some are being blown over, right? Animals are moving in and animals are moving out. We've all walked through these forests before. I'm sure you've all seen that, right? So that would be the equilibrium system. That's the state in which the, what is it, temperate deciduous? That would be the normal state of the temperate deciduous. Okay. Now, that's the equilibrium part of it. The question is, what if then something comes along and disturbs that particular thing? What happens so it can re-establish equilibrium? And that's the second part of this lesson, okay? Now, things that could disrupt ecology, things like volcanic eruptions, fires, droughts. We don't have to worry about tsunamis here, I don't think. That wouldn't be good. What's that? You think that in our location, what, a tsunami from Lake Huron, perhaps? Maybe a double tsunami from Lake Erie and Lake Huron? That could be super catastrophic. I better be careful. I'm putting this on the internet. I'm going to have other teachers mocking me at this point.
Well, I mean, the other day we got with the Star Wars planet.
Oh. Actually, these are just on my Google Drive. I can't actually upload them to YouTube anymore because I think some of the computer people in the world have not allowed us to upload to YouTube. I'm very disappointed. I hope to fix that. Anyway, it's okay. Ecological succession. When a biome, an ecosystem, etc., is disrupted and then let on its own to regrow, we have what is called succession. There is a series of growth patterns that exists from the disrupted dirt back to turning it into the forest. And that's what we want to talk about today. In our case here in southwestern Ontario, every one of those cornfields and every one of those bean fields, human activity. Someone came along, cleared all those trees away, had a big fire, cleared it off, and now, you know, plant crops. But we could imagine that a farmer decides to leave that field. Sometimes they use the term fallow to describe not putting crops in it, and leave that field and let it grow back into a forest. That's what we would call succession. The procedure of letting that area turn back into whatever natural equilibrium that it would be at. Yep. No, correct. The money involved would not be a correct thing. I'm in agreement with you. I'm in agreement with you. But that's what succession would be. It would be a neat little experiment if we could find maybe a little acre and let it go. In actual fact, with my son being an ecologist, I have an acre of grass in behind my place, and my cousin owns the farm around me. I'm tempted to just let weeds grow in my backyard and see how much he loses his mind, because I will then be supplying seeds to his surrounding fields for weeds. I don't think he'd be very pleased. But I'm tempted to do a little experiment because, well, I'm a scientist. So I might do that next summer. Just let my grass grow into weeds and see what all the neighbors say. That could be fun. Okay, so let's talk about then succession. We've got what succession is. Oh, and I hate animations because I wish you would have been writing that. Ecological succession, the process of it should be almost re-establishing or establishing and replacing a community following a disturbance. So it's the regrowth. Now, there are, even though no farmer is going to do that, and you're right, there are little bits of examples where we can see this, even in southwestern Ontario. We can see the disturbance of the soil, and if the conditions are correct, farmers or owners may let that continue to grow, and we can then see a little example of succession when we look around, even in southwestern Ontario. Oh, in actual fact, there's exciting news. I had heard that the town of Petrolia got money to turn the flats back into a wetland. So they want to turn the flats back into what it naturally was, more of a swampy area for waterfowl and things like that. So I think they're going to get rid of those soccer fields, is what I've heard. They're going to let that water now flood and flow into that area and just let it naturally grow. So that'll be interesting. That'll be exciting. Yep. Well, maybe that would solve that. Again, I'm not from town, so I don't know the issues. So if there's a dam issue, then maybe that's the easiest way to solve that. Let the dam fail and then let the area just flood. You know what I mean? And then let it turn back into what it will be. I don't know the timeline. I just heard this on the radio maybe about 3 or 4 months ago. It'll be interesting, though, once they allow that to happen, to keep an eye on that area, because it will then undergo succession. It will start to reestablish the plants. Again, don't take what I said as gospel. Again, I thought I'd heard it on the radio. That would be, I don't know whether that's actually going to happen or when it's going to happen. Question? Something to add? Yeah, again, that's just something that I thought I'd heard. Okay, so let's take a look at 2 examples of succession. And you don't have to draw this picture. This is just for you to take a look the next time you go out to the pinery, all right? And it's not just the pinery that has this take place. I believe, in the whole west coast of the United States, California, et cetera, this is also the same driving factor. So primary succession occurs on new soil, sand, and bare rock. In other words, there was nothing there ever before, and now something has caused this scenario where it can start to grow things. Again, don't worry about drawing the picture. When I was in grade 9, we were studying a similar thing, and I remember we took a field trip out to the pinery. No, we're not going to take a field trip out to the pinery, but it would be cool. And one of our lessons was to walk one of the dunes from the beginning all the way to that established forest. I think it's called oak savanna in this case. It's a very special little biome there. But if you look carefully, when you're at the pinery, you will notice that you've got just sand, nothing growing on it, and then you've got this bump with the little bits of grass on it. That's called dune grass, all right? So what we see here is not just a succession in time as time goes on, but we can see the succession take place as we move in from the beach. Because the beach used to be way back here, and as more sand is made by erosion, right? That sand gets pushed back, and in the end, water levels change. So this used to be a bare dune thousands of years ago, starting out here, but now that time has taken place and succession has taken place, we have a complete established forest further in. But you'll notice that if you've ever gone camping at the pinery, you'll notice how those bumps even go right into the campgrounds, especially at the dunes site, that you then can go right over another bump. And if you look after another bump, there's another dip and another bump, because those were the older versions of the dunes. Okay? So you can see the succession. Succession always starts with simple things like grasses. If you at your house, your parents maybe have a garden and they say, I don't want that garden anymore, so they just let it kind of grow, you'll notice little weeds are the first things to pop up. So those little plants are the first part of the succession. If you were to let it go, birds and various things might come along and drop things like raspberries, which are perennials. Raspberries come up every year, right? If they come and eat the raspberries, maybe they'll drop maybe some maple keys, and then you'll get small little maple trees, right? So then you get larger trees coming in, okay? And that's what succession is, going from that bare dirt to the simple plants to more established kind of perennials, shrubs, various things, and then ultimately you get the mature forest, okay? So I did some checking. This is a classic Google Maps image of the pinery. Nothing magical here, but you can almost see it there. There's the bare sand with a distinct bump here. That would be erosion. But we've all been to the pinery. We know that that little hump happens right there at the beach. Has anybody never been to the pinery? Oh, that's exciting. You got to go to the pinery. Are you kidding me? It's a super ecological system. Anyway, if you've never been to the pinery, there's a dune right in this position here, okay? All right, I'm going to use the mouse just so that... So there's a dune right in this position here, and then it dips down, and then it dips up, and you can see there's taller things here, shrubs, and then it dips down again, and then up again here, and you can see the established trees, all right? So the small plants are first, then the perennials, the one that comes up every year, and then ultimately to a mature forest there at the end. You'll notice there's paths in here, and that's bad to all the ecologists. It's good for all the beachgoers, but bad for the ecologists. Here's another picture that I just found online. This again is the pinery. Again, looking in from the beach. So you've got the dune grass right here. That starts to grab a hold of the sand so things can start to grow on it. There you've got some of the shrubs. And then over that back dune there, you can see the established trees. So again, an example of succession. So for those who have never been to the pinery, if you go, you should check that out. And then here we've got some crazy troublemaker kids. Again, I just found it online. I have no idea who those kids are. But you'll notice all the footpaths here. This is right amongst that first dune where all the dune grass is. What do you notice about the path where everybody walks? Yep. There's no grass. If there's no grass holding on to the sand, what's going to happen to it? What's that? Well, the grass won't grow, but what's going to happen to the sand? Because the grass holds the sand. The grass will hold the sand in the dune. Yep. It'll go back into the water and there'll be no dune. In the end, if everybody walked wherever they wanted, eventually there'd be no grass and there'd be no dunes. You wouldn't see the succession. The succession would stop, all right? So if I go back to this picture here, you'll see here people, and here are the sites in the dunes, people that don't necessarily want to take the road to the parking lot and then walk back along the beach, they cut in through here, and you can see wherever they cut in through there, that the dunes have been damaged, all right? My son, again, worked there and he enjoyed thoroughly yelling at teenagers running on the dunes. He thought that was awesome. And I said, hey, I like yelling at teenagers too. It is fun. Okay, all right. Another type of succession, secondary succession. So this involves a situation where the biome, the ecosystem was established, and so we've got our temperate deciduous forest. Did I say that right? Temperate deciduous forest, like in the forest in around here. Someone maybe clears some of that out, and then for some reason, maybe they build a cabin or a shack or some sort, and they want to maybe have some growth around it. They then let that grow back in. So this is places that already had some plants. They were removed, and now they're able to come back in. So we noticed on the previous one that we can see the succession on the dunes because it's also not just in time, but it's also in location. So we can walk along and we can see the succession. In this case, this is the changes during time. No need to draw it. Just need to, just need to think about it. Again, starting with the little plants, the little weeds. Given enough time, we'll get perennials and bushes. Given enough time, you'll get some softwood trees. And then ultimately, you'll have those old, mature trees that are really tall that then kind of block out some of the sun. And then you've got your biome. All right? Now, I would state that there are examples of where you can see this. Some farmers are really good at working the land really close to the fence line. All right? So let's say you've got farmer A on the left and farmer B on the right. And their land division line, their fence line is in between. Tells them where to stop working the land or plant the whatever. If you've got, say, a farmer who doesn't have that much concern about their fence line, they may only plant a crop maybe there, right? Where the other farmer might plant their crop right up against that fence line to get every little bit of, crop in that space. If you take a look at a fence line, it's almost like a little example of succession. You'll have the little tiny plants growing close to the edge, and then you'll have larger bushes and shrubs closer to the fence line, and if they haven't cleaned the fence line for a long time, you will have trees right along that fence line. Okay? All right? And that's a little example of succession, the fence line itself. Now, I thought maybe about going outside and showing you an example of that, but we can't really see one, and I'm going to get you to do some reading, so maybe we'll save this again for Friday. But if we were to go outside and just look at the fence line up against the football field, right? Or the fence line that's like beyond the football field along, the perimeter. Those fence lines also show a little bit of succession. You don't have grass anymore right beside the fence line. You've got slightly different weeds. Some of those weeds might be a little bigger. Some of them might even be vines that were allowed to continue to grow year after year, right? So at some point, someone had to clear that all out to put up the fence, and then because they couldn't maybe clean it out every year, some succession took place. Eventually, you might get a little tree growing along that fence line, and if you let it grow, you then get to a tree scenario, okay? So that's also an example of succession. So if you want to see succession in action around here, your best bet is to look at fence lines in fields or ditch banks. You know what I mean? Like a ditch that they've cleaned out and then they've let the plants grow back for a while. In the end, you get trees, and then the drainage isn't so good, and then the township comes along and tears all those trees out, and you start all over again. But that's the best place, I think, for you guys to see succession around here. Keep an eye on the ditches and keep an eye on the fence lines, and you'll be able to see that succession. Okay. Benefits of succession: allows ecosystems to recover from natural or human-caused disturbances. Okay. And that's the end of the note part. The second part of this lesson, and again, I'm going to let you work on it. We still have about 45 minutes. If we get to the point where, if we get to the point where maybe even 15 minutes left in class, if we're getting close to being done the little reading sheet, maybe we'll go walk around and I'll point out some of those things along the fence lines so you know what you're kind of looking for if you are interested in looking at such a thing.